Hi guys, so this is the day 1 of the advanced programming class. I would like to cut it short, very short. Why? Because most of you are looking for my technical explanation, right? So let me cut it short about the introduction here. So this course is for those people who actually know some basic programming, because here I can't explain from the very scratch. That if you want to understand from the scratch, then I have already made the 15 days of demo video for basic programming. Do watch that. If you already know some basic programming, then you have to join this course. And in this course, what will I teach? Some basic DS like creating a list, about stack, queues, then BFS, DFS, recursion, advanced recursion. Some data structures we will see. Few data, not all data structures, few data structures. Then we will see HackerRank problems. Okay, we will see HackerRank problems. Then we will see Java 8 features, stream API, date and time API, those kind of things we will see. What you have to understand is this is nothing but the next level of programming. Okay, the advanced programming, that is what you have to understand. If you want to know basic programming, then do attend the basic programming class. This is the advanced programming. Here we will learn advanced recursion. Okay, so cat in a maze, rat in a maze problem, all those kind of things we will see. If a rat is there, in the 0,0th corner of an array, if it has to reach n-1, n-1th index, in what and all ways it can reach? Can it reach or not? How many ways it can reach? So all these kind of problems also we will see. So I hope you have understood what this course is about, and within very short amount of time I have already told what and all we will be doing. Okay. So when the class goes on, right, I'll be keep on telling about the course. So that, like, I know most of you people want to first listen to the class, right? Okay, so let's directly start it. So the first simple program we will see today is binary search. This is a famous question, a famous normal common technique it is. So you as a programmer must know this. So this I'll be considering as the first program. So what is this binary search? What is searching? Searching means to check whether an element is there or not in the object or array or whatever you tell. So let's take an example. Okay, so we have many searching algorithms. Okay, we have something called as linear search. Okay, and one more thing is we have binary search. Many other searchings are there. So what is this linear search? Imagine I have an array like this. I have an array, right, and I have the element 2, 1, 3, 8, 6, 5, like this. I have an element, I have an array. I have one key which is to be found. The key what I want to find is the number 6. I want to find what? The number 6. So if I want to find number 6, what should I do? The normal thinking approach is like this. I have to check one by one element, Hey, is this 6? No. 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 Right? None of, sorry, I am very sorry, right? I am just going with the flow. That's the reason I have made a mistake here. But is this 6? Yes. So as soon as I find the key, right? As soon as I find the key, I will tell, hey, 6 is present. Okay, 6 is present. So what is the time complexity here? You have to understand. What is the time complexity? So time complexity is, how do you calculate time complexity? Okay, so there is best case time complexity, there is average case time complexity, and there is worst case time complexity. What is best case time complexity? Best case time complexity is something like this. You have to imagine that. Okay, what if the key value is 2? If the key is 2, right, you have to understand like this. What's the best case time complexity means? You have to think, hey, what if God is on our side, then how fast will our program run? If God is on your side, don't you think if you want to search the key value 2 and immediately you have 2 in the first element only, that is the best time complexity, right? So when I search here, is this 2? That time only I am getting, yes, this is 2. This is 2, right? So I don't have to waste my time now because the first element itself is the key. So that is the best time complexity. Okay, and the best time complexity, that is represented as this notation. Okay, this tells us the best time complexity. And as you can see, the best time complexity is what here? 1, right? 1 means what? Constant time. It is a constant time. Okay, so this is for best case time complexity. Now there is something which is worst time complexity, that is called as big O. Okay, worst time complexity. So what is the worst case? Worst case is something, that is all of your effort is a waste. That is a worst case, right? Which means if the key is a 10, means you are searching for an element 10, but that 10 is not there in the array. That's the worst case scenario. So we will search here, is this 10, is this 10? No, none of them are 10, which means your efforts are complete waste. You have searched everything, but still you did not find your answer. So don't you think whatever the array length is there, that many times your for loop will run? Yes. So the time complexity is what? N. The time complexity is n. If the n is any size of the array, it will take n iteration, right? If 100 is the size of the array, it will take 100 iteration to find whether an element is not there or not. So that is represented as O. Okay, that's the worst case. And there is something called as here, theta, where it is the average case between the best and worst. How do you find average? Best plus worst by 2, something like that. So I hope you have understood, at least. So what is best, what is average, and what is the worst. Now when I'm talking about time complexity, I don't want the best case time complexity, right? I don't want the best case. I don't want the average case also. I always want the worst case. Okay, whenever someone is talking about time complexity, by default they mean that worst case. Okay, always we have to assume in the worst case what can happen, that we have to see. So that is what we are talking about. Okay, and for the linear search, don't you think the worst case is what if the element is not there? Worst case is n. It will take n amount of time. So this is a linear search. Yes. Next is the improved version of searching, that is the binary search. What is this binary search? I will tell you. Let's see. So for binary search to happen, there is one criteria, that is the array must be sorted first. Okay, the array must be sorted. So let's imagine the array is already sorted. Okay, there is one array here which is already sorted. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Okay. The elements are 10, 15, 30, 35, 40, 50, 80, 85, 86. Don't you think this array is sorted? Yes. This works only if the array is sorted. How? I will tell you. So what is this binary search? Binary search is something like this. Now let's imagine our key, right? Our key is 15, means I have to find whether 15 is there or not in the array. So how will the binary search use this algorithm? I will tell you. Since it knows it is already sorted, okay, since it knows it is already sorted, what it will do is, first it will find the middle point. Okay, it will find the middle point. Now how do we find the middle point? Is like this. We should have a starting element, okay, and ending index. Don't think the starting index is 0. Yes. What's the ending index is 8. Ending index is 8. What is 0 plus 8? 0 plus 8. If you want to find the middle element, okay, to find the mid element, the formula is starting plus end divided by 2, right? This is how to find the mid element. So starting is 0. 0 plus 8 by 2. 0 plus 8 by 2 is 4, which means 4 is our mid now, right? 4 is our middle element. Now I have to check whether this key 15, is it equal to middle element? That's the best case. Is it equal to mid? No. 15 is not equal to mid, right? Yes. So what is the key value now? 15. So you think and tell me, if the array is already sorted, right? 15, 15, is it less than 40 or greater than 40? Don't you think 15 is less than 40? And if it is less than 40, somewhere around here only your array, 15 will be. Tell me, will 15 ever be on the right side of the 40? Not at all. 15 can't be on the right side of the 40, right? Why? Because 15 is less than 40, not greater than 40, and it is guaranteed that array is sorted, which means 15 is definitely less than 40, which means somewhere around here, you have your 15. Somewhere around here you have your 15. That is the logic which I am using. Okay. So now somewhere around here, so it can be here, it can be here, it can be here, it can be here, but can it be here? It can't be here. Okay, it can't be here. This location I should not tell. Why it can't be here? Because mid value, is it in the mid or not, I have already checked, right? Yes, that's the reason. It can be only in this location. It can be only in this location. Now what's the new starting value? 0. What's the new ending value? 3. So I'll update it. New ending value is 3. I have updated it. After that, I want to find the middle element. And how do I find the middle element? Start plus end by 2. Okay. What is start value? 0 plus 3. What is 0 plus 3 by 2? 0 plus 3 is 3. 3 by 2 is 1.5. But 0.5 is lost. Answer is 1. So mid, you have mid as what? 1. I will split that in the 1th index, and now I will check whether this 15 is it equal to key. Yes, it is equal to key. It is equal to key. Now you think and tell me how many comparison I had done. 1 split, and in the second split only I got my answer. So don't think here time complexity is very efficient. Let me give more example. Okay, so imagine there is an array, right, from 0, 1, 2 and so on till 100. Till 100 we have an array full of elements. If it was a linear search, I want to find whether 99 is present or not. If it is a linear search, tell me how many iterations it will take. 99 iterations it will take, because one by one it has to check whether 99 is there or not. Agree? Yes. So let me not take 99, let me take example 35. Let me take the example 35. I want to check whether 35 is there or not. So how many iterations it will take? It will take from 0 to 35. 35 iterations it will take. But let's see in binary how many iterations it will take. So it will find the middle element. How to find the middle element? 0 plus 100 by 2, that is 50. Okay, so what is the key now? Key is 35. Okay, is 35, is it equal to 50? No, 35 is not equal to 50. So 35, which I want to find, is it left side of the 50 or right side of the 50? 35 is less than 50, so it is left side of the 50, like this. Okay, it is left side of the 50. So what we will do is, again we will find the middle point. We will find the middle point now. From 50 and 0, the middle point is what? 25. Okay, is 25 equals to 35? No, 25 is not equal to 35, which means 35, you think and tell me, is 35 greater than 25 or less than 25? 35 is greater than 25, right? Which means 35 will be right side of the 25. So that is why we will again split by half. So let me do comparison here. The comparison was, first comparison was what? 50, right? The second comparison was 25. The third comparison between 25 and 50, I want a middle point now. So how do I find middle point? 25 plus 50 by 2, that is 75 by 2. 75 by 2 will be 30, I think 3, okay, 34. 37, okay, 37, it will be 37. So we will split at 37, okay, 37, and we will see, okay, is 37, is it equal to 35? No, so the third comparison was 37. Okay, is 37 equal to 35? No. So 35, you tell me, is it less than 37 or greater than 37? 35 is less than 37. That's why again it will split by half. So fourth comparison it will do. Okay, so how do I find the middle element now? Again, because if it is not the key, then somewhere around there is a key, right? So again it will split by half. So if I split by half, it is 25 plus 37 by 2. So that will be 62 by 2. That will be 31. So we will split at what? 31. Is 31 equals to 35? No, 31 is not equal to 35. Okay, so 31 is the next comparison. But we have to find the middle point again. So is 35, is it greater than 31 or less than 31? 35 is greater than 31, means somewhere around here, that 35 will come. we will see that. So we have to find a middle point, that's why it is like this, that is 31 plus 37 divided by 2. So that is 68 by 2, that is 34. So we got the fourth element 34. So I mean the fifth comparison is 34. Is 34 equal to 35? No. Okay, no. Again we have to do the sixth comparison, right? Sixth comparison. So 35, is it greater than 34 or less than 34? 35 is greater than 34. Again I have to split by half. So 34, I want to find the middle point. 34 plus 37 divided by 2. So that will be 7 plus 4 1, 71 by 2. 71 by 2 will be 35.5. that 0.5 is lost, answer is 35. So we'll split at 35 now. We'll split at 35. Sixth comparison is 35. Is 35 equals to 35? Yes, we have found the key element. We have found the key element. So now think and tell me, don't you think it has taken sixth comparison only? Yes. If it's a linear search to find 35, it would have taken 35 comparisons. But in a binary search, we are able to do this in a sixth comparison only. That is why binary search is more efficient than your linear search. That's why it is famous. Okay. So now let's see how do we write a program for this, right? Okay. Once you have understood, okay, this is how it is working. We have to make a test case now. We have to make a test case. Okay. Okay. So let's make the test case. So we will take this test case now. Okay. Let's try to trace it. So what we'll do is we will generate a program from the scratch by our thoughts. Okay. So first we'll think what has to happen, right? Then whatever you're thinking, that will transform it into program. You don't have to by heart anything here. So now, okay, first definitely my start has to point here, right? My start has to point to 0. My ending has to point to 0. This is what I have to do. Because if I only know my starting and ending, then only I can find the middle index. Okay. So initially my let's say the iteration 1. In the iteration 1, my starting has to be 0. Ending has to be what? Ending has to point to last index. And last index is nothing but length minus 1, right? Length minus 1. Array length minus 1. Array length is 9. 9 minus 1 is 8. And I told in the basic programming, always last index is nothing but length minus 1. So I have starting and ending. Then definitely I have the mid. That is start plus end by 2. That is 4. I have the mid. Okay. After I have this, what should I check? I have to check that, okay, okay, my key, I have a key value as, let me tell, right now my key value is 30. Let not it be 15, let it be 30. My key is 30. So I will split this in half. So you think and tell me, is m value, don't think m value is 4. M value is 4. M value is not 40. M value is 4. 4 means it is the mid element is present in the fourth index. That's why I have to check first. Hey, if AR of M is it equal to key, let this have to check. Okay. If it is a key, then this is the answer. Okay. But this won't be the case every time, right? So M value is 4. M value is 4. What is AR of 4? 40. Is 40, right? Is it equal to 30? No. Okay. No. That's why what I'll do is, let me not write this case, okay? Because let me explain the other case. So now 30, tell me, is it less than 40? Yes. That's how I'll check, hey, if 30, where is 30 stored? In the key. If it is less than, if the key is less than AR of M, right? If the key is less than AR of mid, what is AR of M? AR of 4, right? M value is 4. That is the mid index. What is AR of 4? AR of 4 is 40. What is the key? 30. I am checking, is the key what I have to find, is it less than the mid element or greater than the mid element? Okay, if it is less than the mid element, yes, in this case it is less than the mid element. Then what do we have to do? What do we have to do is, don't you think I have to tell, hey, don't search here at all. Don't waste your time searching there, because 30 is present before 40, not after 40. So in that case, end, whatever is here, don't think it has to be shifted here. Now don't think a end has to be shifted here. Why do you want to point to an index which mid element is not the case? Because we already know if key is equal to mid, then this was the answer. But end is not there, end is here, mid minus 1. Previously what was the mid value? 4, right? Okay, so once I get to know that key is less than that, okay, somewhere around key is here, right? Tell me, is my starting index changed? No, my starting index did not change, it is as it is, but ending index has a new value now. That's why I'll tell, if this is the case, then the new ending index is nothing but previous mid value minus 1. So in m minus 1 I will tell, mid minus 1. This is what I will tell. For this, if there is one else, right, there is one else part. Okay, let me write the code this side. Whatever code I'm thinking, I'm writing it here. Watch here. So if the key, if it is less than AR of mid, if it is less than AR of mid, means key is on the left side, right? Okay, if key is on the left side, my new ending index is mid minus 1. But for this, if there is one else if, what is that else if? What if the key, if it is greater than AR of mid, right? Right, watch here. What if the key is greater than AR of mid? Then what we have to do, I will tell you, right? If the key is greater than AR of mid, like this, watch here. For example, let's imagine my key value, right? Now let me take a different case. Okay. Let's imagine my key value is what now? My key value is 85. Okay, my key value is 85. So I have found the starting index, I have found the end index, and I have found the mid index. I will split at the mid index. Is 85, is it equal to 40? No. So 85, is it before 40 or after 40? 85 is after 40, which means 85 will be right side, right? 85 will be right side of the 40. So that's what I am checking here now. Okay, that is now don't you think key is greater than the mid element 40? Yes. Okay, key is greater than the mid element 40. That is why here key is greater than mid. This statement will execute. If this statement executes, what should I say? Right, I'll tell you what we have to say. If this is the case, somewhere around here our key value will be there, which means ending index will be same ending index only, but my starting index will update from here to, this is the mid value, mid plus 1. This is my new starting value. That's why what I will tell is, if this is the case, ending should not update, but my starting should update. Okay, my new starting value is mid. This is the mid value 4 plus 1. I will tell. So here I will tell the new starting value is mid plus 1. This is what I will tell. Okay, now it is updated now. Okay, let's update. Right, let's update. So I want to search for 85. Okay, so let me not put a bracket. Because it will take consume space there. If key is less than, then ending is mid plus 1. Else if key is greater than AR of m, then it is starting is mid, ending is mid minus 1. Okay, starting is mid plus 1. This is what we have written. Okay, this is what you have written. Now there is a third case, that is what if key is equal to mid. That we will see later. Okay, now because of this, now let's see what is the key now. 85 is greater than 40. This condition is true. So my start will update to m plus 1. Okay, what's the m value? 4. What is 4 plus 1? 5. My starting will update to 5. After this what I want to happen is, I have a new starting value, I have the ending value. Again I want to find the middle element. Don't you think? For this array, again I want to find the middle element, which means, okay, what I will do is I have to write this in a loop here, because every time I have a new starting value and new ending value, I want mid to be what? Starting plus end divided by 2. So this should keep on happening This should keep on happening. This whole process should be inside a loop now. I hope it is clear. It should be in a loop. So again, what? I will find the starting. Okay. So what is the starting now? Mid is equal to start plus end by 2. So here I will find the mid. What is 5 plus 8? 5 plus 8 is 13. 13 by 2 is 6.5. So answer is 6.5 is lost. Mid element is 6. Okay. So that will be splitted now. That will be splitted. Is 85, is it less than 50 or greater than 85 less than 80 or greater than 80? Let's see. Key value is 85. Is 85 less than AR of what is the M value? M value is 6. What is AR of 6? AR of 6. AR of 6 is nothing but 80. Is 85 less than 80? No. Then it will check the else if condition. What is the key value? Key value is 85. Is it greater than 80? Yes. So this condition is again true. So your S value will update to M plus 1. What is M value? 6. What is 6 plus 1? 7. Your S will update to what? 7. Right? Your S will update to 7. Now, so as soon as I get the new S value and the new E value, every time my M will update, middle element will update. My M value is starting plus end by 2. What is 7 plus 8? 7 plus 8 is 15. What is 15 by 2? 15 by 2 is 14.5. 15 by 2 is 7.5. So that 0.5 is lost. So answer is 7. Mid is 7. And now we are splitting here. Okay. Now we are splitting here. So is 85, right? What is the key value? 85. What is M value? 7. What is AR of 7? Is 85 less than 85? No. Is 85 greater than 85? No. Which means 85 is equal to 85. That is why you have a last option, else if part. That is, if these two conditions are false, then definitely that key is equals to AR of mid. Okay, key is equals to AR of mid. If key is equals to AR of mid, we have found the answer. If key and the mid element are same, we have found the answer. But the question here is, we should tell that we have found the answer by returning the index of the element. What is the index of the element? 7. So system.out.print, I have to print that M value. What is this M? This M is nothing but that middle index here. So I'll print that M. Okay. That is, I have printed 7. So now we have to keep on doing this procedure. Don't you think? Yes. Okay, starting should be always less than the end. See here, starting is 5 and ending is 8. Starting should be less than the end. Starting should not cross the end, right? Starting should always be less than the end. This is what you have to tell. Now let's see one more test case. Okay, let me take the number 1 2 3 4 5 6. Okay, let me take this 1 2 3 4 5 6. Let's write the indexes. So now I would like to search for an element which is not there in the array. Okay, so I want the key. What is the key now? The key is 10. Okay, I want to search for 10. Whether 10 is there in the array? No. So if I have to see if the key is 4, okay, let's write it is 10 20 30 40 50, okay, 60. Okay, if the key is 40, you have to tell 40 is present in which index. So that's why the answer will be what? 3, right? The answer will be 3. I hope you are understanding. We have to return the index of an element. Okay, so now what we will do is we will search for an element which is not there in the array, because I would like to show you that you have a start and end. Then how will you get to know that element is not there, right? How will you get to know? That we will check. So let's imagine our key is 100 now. I want to check whether 100, what's the index of 100. Okay, so what should be the answer here? 100 is not there in the array. Then how will you represent in your answer that 100 is not there in the array? Can you tell 100 is not there in the array by telling 0? No. If your answer is 0, it means that 100 is present in the 0th index, like that. But if you write -1, it means that 100 is present in -1th index. But is there any -1th index in an array or string? No. It means that -1 by default means element is not there. Okay, that's the meaning of -1. And most of the time you will see in many logics, in many algorithms, you are returning -1 when you find, when you find there is no answer. Okay, now okay, I want to find 100. So what is the thing here? Initially my starting is 0, ending is the last index, that is 5. Mid is nothing but start plus end by 2, 0 plus 5 by 2, 5 by 2 is 2. So we will split in middle, okay. So is 30, right? Is it less than, what is the middle element? Okay, air of mid, that is 30, right? And key is 100. Is 100 less than 30? No, if condition is false. Else if, is 100 greater than 30? Yes. If 100 is greater than 30, then somewhere around here you have the element 100, somewhere on the right side. So that's why what you will do. What you will do is, if somewhere on the right side you have the starting here, you have the ending here. Ending should be same, but starting should go for, this is mid plus 1. So starting is mid plus 1 we will do. So mid value is 2, 2 plus 1 is 3, your starting will be 3. So you have a new starting value, new ending value. And always your mid value is divided by 2. So 3 plus 5 is 8, 8 by 2 is 4. So we are splitting it 4 now. Okay. So what is air of mid now? 50. Okay. So is the number which we want, 100, is it less than the mid element 50 or greater than? Is it less than? No. But 100 is greater than the mid element 50. Means somewhere around here you have your 100. Right? Somewhere around there you have your 100. See, still there is one index which you have not solved, agree or not? Still that I have to search. So what will happen now? Okay, now we got to know that 100 is greater than 50. So this will execute again. S is equal to m plus 1. S is equal to, what is the m value? 4. M value is what? 4. Okay. So what is 4 plus 1? 5. So you will get that element. What is mid element? S plus end by 2. 5 plus 5 is 10. 10 by 2 is 5. Okay. 10 by 2 is 5. So now you are searching you got your mid element 5. So it will split at 5 like this. It will split at 5. So what is your starting? Ending is also same. Starting is also same now, right? And mid is also same. All of them are same. So what is the number? 60 here. What's the number? 60. So is 100, is it less than 60? No. But 100 is greater than mid? Yes. 100 is still far off the 60. Agree or not? 100 is still right side of the 60. In that case, if 100 is still right side of the 60, right? Then what will happen? Then 100 is still right side of the 60. This will execute again. S is equal to m plus 1. What's the m value? 5. What's the s value? Now m plus 1, that is 6. Which means, now don't you think, imagine there is a 6th index and starting has gone here. Yes. If ending and starting are equal also, no problem. But if starting crosses the ending, then there is a problem, meaning there is no element left. Actually, initially my starting was here, ending was here, right? Yes, always starting should be less than or equals to ending. It can go equals to ending. See, it has meant equals to ending, but it should never cross ending. Okay, so we have to keep on doing this procedure until our starting is less than or equals to ending only. Okay, let me take one more example for you guys, because when you take the test cases, then only you will understand more. Let me search for an element 35. Okay, somewhere around, actually 35 should have been there, but 35 is not there. Then what will happen when we search it? Is 35 there in the array? No. Let's see how to do it. So initially, right, we have our starting as 0, ending as 5. Mid is 2 now. So we will split it to 2. So we will compare now. Is the key 35? Is it less than 30? No. Okay. Is 35? Is it greater than 30? Yes. Means 35 is somewhere around here. We got to know. That is why I will tell ending is the same, but starting should shift here. That's why the new starting is the mid value 2 plus 1. So 2 plus 1 is 3. So you will get a starting value. As soon as you get your starting value, always your mid should update. 3 plus 8, 5 is 8. 8 by 2 is 4. So you will split here now. You will split here. So now if I try to neat it, so starting is here, ending is here. Okay. 50. So now this AR is 50. So is 35, is it less than 50? Yes, 35 is less than 50. If this is the mid element, 35 is not on this side, but 35 is on this side. That's why what we'll do now is, in that case, if 35 is this side, then ending is mid minus 1. What's the mid value now? 4. What is 4 minus 1? 3. What is 4 minus 1? 3. So your ending will become what? 3. As you can see, now starting and ending is same. But if it is same also, we should execute. So what will happen now is, your ending will be, starting and ending is here. Then you have to find your new mid value, that is starting plus ending by 2. 3 plus 3 is 6. 6 by 2 is 3. So you will split here now. You will split what? Here, 40. So this is the last option which is remaining for you. That is, now you are searching, right? Is 35, is it less than 40? Is 35 less than 40? Yes, 35 is less than the mid element. Means 35 is somewhere around here. But we have already seen that it is not here. Okay. But yes, 35 is less than 14. In that case, what are you doing? Ending is equal to mid minus 1 I am doing. Okay, what am I doing? Ending is equal to mid minus 1. What's the mid value? 3. Mid value is 3. What is the ending value? Mid minus 1. What is 3 minus 1? 2. Yes, which means what happened now is, ending has come here. Now don't you think starting has reached, crossed ending? Yes, starting should be always less than ending, but it has crossed the ending, which means you have not found the element. We have not found the element. Okay, either starting can cross the ending or ending can come before starting. Whatever it is, element is not there. I hope you have understood. Okay, so let's write the program here. Int AR is equals to, right, I'll write the array, that is, okay, 10, 20, 30, 40, 50, okay, and 16. Okay, now I have to create int s is equals to 0, right? Starting is 0, and int end e. What is the ending index? Is AR dot length minus 1. That's the ending index. Okay, now I'll write a while loop. What is that while loop? I have to check each and every time, hey, whether my starting, is it less than or equals to ending. If it is less than or equals to ending, then only keep on doing the procedure. What procedure? Finding the mid value and doing all these things. Okay, so as soon as I have starting and ending, if the starting is less than ending, then keep on doing the procedure. What's the procedure? First to find the mid value. So int mid is equals to, like this, starting plus ending by 2. Starting plus ending by 2. This is what I'll do. As soon as I find my mid value, I'll check one condition. Is mid value, is it less than AR of the middle index? If it is less than the, sorry, it's not mid, okay, it's, if the key, right, if the key is less than AR dot mid, so I have to write what is key here. I'll write int key is 100 for now. I'll tell int keys, or let me tell 10. I'll check like this. If key is less than mid, means what? Key is somewhere here. Okay, if it is less than half, start will be same, okay, but end will change to mid minus 1. That's why end will change to mid minus 1. How it is mid minus 1, I have already explained. For this, if there is one else if key, if it is greater than AR of mid, right, if it is greater than AR of mid, then start is equals to mid plus 1. The last part, else if, actually if you write else also, that is enough. But if key is equals to AR of mid, right, if keys, then we have found the answer. Then system dot out dot println, right, what we can tell is, okay, we can tell found, right, we can tell for you found the, okay, found key. What is the key? Plus key, okay, variable, found key in, okay, found key double quotes in the index, plus what is the index here? Mid is the index, agree or not? Because for an, this is the index, agree? Yes. So we can tell like this. So I'll compile now and I will execute. See, it is telling found, I have found the 10 in the index 0. But why it is going infinite loop? Why? Because simple. As soon as you found the element, don't you think you have to break? Yes. As soon as we find the key, you print and immediately you tell break like this. That's it. So I'll compile and I will execute. It has found 10 in the index 0. I will search for the key value 20. Okay, so it has found 20 in the index 1. Right, now what will happen if I search for something like 200? Is 200 there in the array? No, but actually what it should print? It should print -1. I'll execute, it is not printing anything, right? So how will I get to know that it has found the key or not found the key? Remember, there is something called as slap logic, okay, which I have covered in the basic programming. So it's like this, okay, we will slap a person, okay, we will slap a person. So imagine that me and you, the person who is watching, we are sitting in a room. I have asked you, all your friends are waiting outside. We are waiting outside the hall, Viva hall. Okay, we are doing Viva now. So I'm asking you a question, and now you have not answered. So what I'll do is I'll give a nice slap. Okay, so one nice sound will come. Now don't you think the outside people got to know that hey, this person has not answered correctly, right? So if some slap happens, means some event has occurred. But if slap doesn't happen, nothing has happened. Everything is proper, like that. Like that it is. So that's why what I'll do is see all about this logic. The stories is already covered in the basic programming. So I hope you already know. This can also be called as a flag variable. Okay, you might have heard about this flag variable. So this is to indicate whether something has happened or not. So what I'll tell now, I'll tell slap plus. Initially I will tell here int slap equals to 0. Now you think and tell me, if slap plus has to happen, if slap plus happens, it means that it has found the answer. Agree or not? If slap has to increment, it means that it has found the answer. But if slap value is still 0, what does it mean? After this program, right? After this program, I'll check, hey, if my slap value is it equal to 0. If my slap value equal to 0, what does it mean? It means that control has never come here. If control has never come here, it has never found the key, which means that element is not there. That is why if slap equal to -1, system.out.println, I have to print -1 as the answer. Okay, so for 100, okay, I'll execute. See, -1 is the answer. Okay, if I write any number, now what will happen is 2000. Is 2000 there in the index? No. So this else if will never execute. Means slap plus will never happen. It will be the same as it was initialized. So if it is 0, it will print -1. That's what it is. So now if I tell 30, okay, now what will happen? There is a point in the future. Where this element will satisfy. So slap plus will happen. So slap value is what now? Slap value is 1. It will print it has found the key. Control will come out. But when control comes out, it will check, is slap value 0? Hey, no, slap value is 1. No. Is 1 equal to 0? No. So it will not print this. Simple. So I'll compile and execute. The 30th index is C2. I hope you have understood binary search here. Now let me talk about time complexity, but before that you can take the notes for this. Okay, you can take the notes. So now what we can do is we can initialize multiple variables in one line, right? Yes, by separating comma. You can do that. Okay. Yes. And you know that if there is only one element, we don't have to write the bracket. Why I am doing this? Because I want you to take the notes in one screen, from one screen only. That's the reason. Okay. But if there are multiple statements which has to be done, then you are putting brackets. Okay, now everything is in one screen. Now you can take along with the output also. Yes, please take this notes. Take this notes, write it down. Heading is binary search. Okay, this is the program, that is the output. Now let's talk about the time complexity here, okay? Because this is important to understand merge sort also. So tell me, how do you calculate time complexity? You have to calculate time complexity by not best time, by not average time, but by the worst time. How do you calculate worst time? You have to imagine a what if the element is not there in the array. That is how you have to do it. Okay. Now let's try to guess here. Okay. If I have an array of the size, let's say 4. What's the array size? 4. How many comparison I have to do so that I will reach the end of an array? Right? I will reach the end of an array. How many comparison I have to do? Let's see. So here what's the n value? N value is 4. The size of the array is 4. Let's see now comparison. 0, 1, 2, 3 is the index. I have 10, 20, 30, 40. I want to search for 50. So I'll find the starting is 0, ending is 3, right? If I want to find the mid, starting plus ending by 2, that is 1. So I'll search first here. Here what's the key? Key is 50. Is 50 equals to 20? No. So is 50 less than 10 or less than 20 or greater than 20? 50 is greater than 20, which means somewhere around here you have your answer. So initially starting was 0, right? Don't you think starting and ending should be here? Yes. So starting will be mid plus 1. Mid value is 1. 1 plus 1 is 2. So starting will come here and ending will be same. But the mid will be 2 plus 3 by 2. What is 2 plus 3? 5. 5 by 2? 2. Mid will be 2. So now we are splitting here mid element. So 2 comparison we have done. Okay. 2 comparison we have done. Okay. So number of comparison is 2. We have not found the answer. Again here I will do. So number of comparison is 3. Okay. So what I can tell is number of comparison is 3 now. For n value 4, right? How many comparison we have done? We have done comparison. I'll make a table. Okay, I'll make a table here. Let me erase this so that we'll understand. For n value, okay, how many comparison? For n value 4, I did 3 comparison. For n value 8, how many comparison I will do? Okay, let's see. Now for n value 8, right? If n value is 8, means there are 8 elements. 1, 2, 3, 4, 5, 6, 7, 8, 10, 20, 30, 40, 50, 60, 70, 80. I will search for 90 now. So 0, 1, 2, 3, 4, 5, 6, 7. And mid element is 0 plus 7 by 2, 3. 1 comparison. 90 is greater than 40. 3 plus, starting is 4. 4 plus 7, 11 by 2, 5. Second comparison. So next is this, right? So what is 6 plus 7? Because 90 is still somewhere here. That's why this is the starting, this is the ending. What is 6 plus 7? 6 plus 7, right, is 13. What is 13 by 2? 6. Third comparison I have done, right? Here also I have not find the element. So I will tell, okay, starting, this is a mid element and it is not the starting will increment here. So starting plus ending by 2, this is only the mid element. 4 comparison I had done. So let me update the table, that is 4 comparison I have done. For n value 2, how many comparison we have to do? Right? See, this is very important in programming. That is, you have to check, for what n value, what will be the comparison. Okay, this technique is important. So if n value is 2, right, 2 elements are there, 10 and 20. I have to search for 30 now. So 0 and 1. Okay, this is the starting, this is the ending. Mid element is 0 plus 1 by 2. 0 plus 1 by 2 is 1 by 2, that is 0.5, that is 0. So the mid element is 0. I'll split here. Is 30 equals to 10? No. 30 is right side of 10. So I'll split here again. This is also not the answer. So 2 comparison, right? Watch here carefully. So 2 comparison I have done. Okay, 2 comparison I have done. Now for the 16, right? For 16, what will be the comparison? Okay, what will be the comparison? Let's see. For 16, let's see. watch here, imagine we have 16. Okay, so 16 means it is 10, 20, 30, 40, 50, 60, okay, 70, 80, 90, 100, 110, 11, 120, 13, 14, 15, 16. Okay, so we have 16 elements. So how many comparisons it will take if the element is not there? That is the worst case scenario. Okay, so let me write the indexes here: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15 index. So this is my starting. Now this is my ending. If I want to find the mid is nothing but starting plus ending by 2. 0 plus 15 by 2, 15 by 2 7.5 means 7. This is my mid element now. So I will cut it here, and the key which I want to find is 200 now. So is 200, is it equal to 80? No, 200 is not equal to 80. Okay, is 200 less than 80 or greater than 80? 200 is greater than 80, means 200 is somewhere around this side. Now don't you think half of the comparison you have neglected that? Yes, we don't want that. So 200 is somewhere around that side, which means ending is this ending only, but starting is not here. The starting is here. So the new starting value is old mid value plus 1 I have to tell. Okay, I got the new starting value. So now if I get a new starting value, I need a new mid value. So one comparison I have done. Okay, the second comparison, 8 plus 15 by 2. 8 plus 15 is 23. 23 by 2 will be 11. Okay, 11.5. 23 by 2 is 11.5. So 11, it is 11. So this is my new mid element. So is 200 equal to 120? No. Is 200 less than 120? No. 200 is greater than 120. Means somewhere around this side I have the number. So I got to know this is not the starting number. Definitely this is the starting number is mid plus 1. Okay, this is the starting number. Okay, 2 comparison I have done. So 2 again I have to find, I got a new starting value, so I have to find a new mid value. 12 plus 15 by 2. 12 plus 15, 27. 27 by 2. 27 by 2 is, okay, 27 by 2 is 13. Okay, 27 by 2 is 26 by 2 is 13. So 13 is a mid value. This is the mid value now. Is 200, is it equal to AR of mid? 200 equal to 140? No. Is 200 less than 140? No. 200 is greater than 140. So somewhere around, so this side, starting comes here. What is 150? 14 plus 15 by 2, that is 14. So fourth comparison I am doing. Is 150 equals to 200? No, somewhere on the right side. So this is my mid. So now starting comes here, because starting is nothing but mid plus 1, right? That's why starting will come here. Again we will split by half, right? This is not the element, then starting will go to the further and we get to know element is not there. But how many comparison we have done? 1, 2, 3, 4, 5 comparison I have done. Okay, so what I can make a table now is that we have done how many comparison? 5 comparison. Okay, now what you have to understand here is something like this. That is, I will subtract -1 from all these numbers, because 5 comparison is almost equals to 4 comparison, right? I'll write like this: 5 is almost equals to what? It is almost equals to 4 comparison. 2 is almost equals to 1 comparison. 4 is almost equals to what? It is equals to 2 comparison, 3 comparison, agree? And 3 is almost equals to what? 2 comparison, agree or not? Yes, I can tell 3. See, when you're talking about a large number, right? 1000 and 999 almost same, right? For example, someone promised you, hey, I will give you 1000 chocolates, and when they bring the chocolate, one chocolate is lost. They will give you 999 chocolates. One chocolate is lost. Will you be angry? No, right? It's almost same. It's okay. So that the same logic we'll use here. 3 is almost equals to 2. 4 is almost -1 I am doing. Why? Because now I am able to notice after I do -1, right? Whatever number I have here. What is 2 power 4? What is 2 power 4? 16. What is 2 power 1? 2. What is 2 power 3? 8. What is 2 power 2? 4. Right? Yes. That's the reason I have done. Okay. Now what we'll see is we'll tell like this. Okay. We'll tell that if when n value was 4, when n value was 4, agree? When n value was 4, it executed, okay? It executed how many times? It executed 4 times. When n value was 16, it executed, it did comparison. It executed how many times? 4 times. 4 times it has to do comparison. So now the question is, right, from the n, how do I get that 4? Because for example, imagine that when your n value was 4, if it executed for, let's say if it ran for, okay, let me write like this. If your n value was 2, if it ran for 200 times, right? Or let's say if it ran for 4 times. If your n value was 3, imagine you had a program which ran for n times. If your n value was 5, imagine your program ran for 25 times. Imagine if your n value is 10, imagine if your n value is 10, your program ran for 100 times. Then you can easily tell the time complexity is n square. What's the time complexity? N square. Because if your n value is 2, your program will run for 2 square times. If your n value is 3, your program will run for 9 times, 3 square times. So here was the time complexity n square, big O of n square, because this number is nothing but square of this number. So now I have to think, how do I get this 4? Because if I think how do I get this 100, 100 is nothing but n square. I have to think how do I get 25, 5 square. But now I have to think how do I get this 4. For that, what we will do is like this. I'll tell you one concept, that is, do you know that there is a formula, right? Let me erase this. In the log there is a formula. What is that formula? Let me tell you. Log of x with the base x is 1. Agree? Yes or no? For example, log 5 to the base 5 is 1, log 10 to the base 10 is 1, like that. Okay, that is one formula. One more formula is log, maybe let's imagine you have a base b and a to the power n. It can be written as, if something is there for the power that can be brought this side, so it is n log a to the base b. That power will be shifted this side and we can write like this. Okay, so this is that important, this is that important which we need now. Okay, that is important. So now let me write something like this. Log of, I am telling the time complexity is what? I am telling the time complexity is log of n. This is the time complexity, which means if n value is 16, if n value is 16, your program will compare, your program will execute for log 16 times. Okay, this is what it is. How? Let me show it to you. Can I write 16 as 2 power 4? Yes. Can I write 16 as 2 power 4? Yes. If I write something to the power 4, can that 4 be brought this side? Yes. We can write this as 4 log 2. We can write it as 4 log 2. 4 log 2 to the base 2. Agree? Yes. 4 log 2 to the base 2. I'll take a log of the base 2 now. And you know that log 2 of the base 2 is 1. So that is nothing but it is 4. So don't you think we got our answer? It will execute for 4 times. Yes, it will execute for 4 times. I hope it is clear. One more example. If your n value is 8, our program will execute for how many times? Log 8 times. Log 8 can be written as with the base 2. Okay, log 8 is nothing but 2 cube. And you know that it can be written as 3, because that power comes this side. So it is 3 log 2 to the base 2, that is 3. See, don't you think when my n value is 8, my program will execute for log n times? Yes, that is why people will tell that for binary search, your program will execute for log n times. The time complexity is log n. The worst case time, definitely. Okay, the best case time complexity is a constant time. That's a different case, right? For example, in the array, right? For the first split only you will get your array. If your key is 20, for the first split only you will get your element. But that doesn't determine your complexity, okay? Because that we can tell it as luck, So we have to always imagine, what if our luck is completely bad, how much time your program will execute. That is our time complexity. So I hope you have understood here why the question comes, why we tell it as log n. Okay, so to find one element, how many what's the time complexity? Log n. To find 2 element, 2 log n. To find 3 element, 3 log n. Agree? To find 4 element, 4 log n. To find n element, n log n. I hope it is clear. And this n log n time complexity is of merge sort. When I am teaching you merge sort, that time I will tell you. So, but now I hope you have understood. To find one element, agree? How many? What's the time complexity? Log n. So to find 2 element, it is 2 log n, and to find all the elements, it is n log n, which will be for merge sort. Okay. But now you have understood it is log n. So what I would like to do is, I would like to take screenshot if you want here. Okay. I mean not screenshot. I mean in the sense, if you want notes or anything, you can take it down. Okay. Yes, it is messy, but your notes should not be like that. Whatever you have understood, you have to write it down. Why I am not giving that much importance to the notes is because you have to understand that is important. Notes is secondary. Notes is something which you have to write, which you have understood. Notes is not something which I will be providing and you will be copying it down as it is. No. Notes should be out of your thoughts. Why? Because when you do like that, then only when you open your book, immediately thing will flash to you. Okay? Immediately the thing will flash to you what has to be done. Please remember that. Notes is something which is not which I will be giving, which you should write on your own. Okay. Now, I hope you have understood how this binary search is working. Okay. Now tomorrow we will see about linked list. Okay. We will see about linked list, how to create a node, all those things. But to do that, we have to talk about classes and objects. So tomorrow, first we will talk about classes. How do you create an object? What will happen when you create an object? Then I'll come to linked list. But today's class doesn't end here. Okay. In today's class, it is 1 hour, right? I have one more topic to tell you. That is the fastest algorithm for printing the prime numbers. Okay, the normal prime number program, whatever you know, which are taught in the basic programming, it will take a lot of time, but this is not like that. Okay, this is very fast. How you will get to know? So this is called as it is very difficult to pronounce, sieve of sieve. Okay, if you want me to spell, it is like this: sieve of erythronesis. Okay, something, spelling is there, I forgot it. Sieve of something like this. Okay, so what is this? What is his logic? It's very beautiful. Okay, so the task, we have been given a task. Okay, we have to print all the prime numbers from the number, okay, from the number 2 to the number 20. We have to print all the prime numbers from the number 2 to number 20. Okay, so how do we do it? Let's see. So we have to print all prime numbers from 2 to 20. So what is a prime number? Prime number is a factor. Prime number is a number which doesn't have any factors. Agree? For example, 5 is a prime number. Why? It doesn't have factor other than 1 and 5. Like that. So what we have to do first is, we have to do something like this. Okay, they want the number, right? So what I'll do, I'll create one array. Okay, so let's imagine there is number 2 here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's take 21 also, why not? And 22. Okay, so you have to print all the prime numbers from 2 to 22. If you have to print all the prime numbers from 2 to 22, then you have to create one array like this. Not actually like this, but I'm trying to explain you the logic first. Okay, so first, whatever first number you are seeing, that is a prime number. Are you understanding? So there is something as tick mark and wrong mark. Okay, so initially everything is tick mark only. Are you understanding? Initially everything is tick mark, which means you are assuming that this is the algorithm how it goes. We have to assume that everything is prime number. We have to assume like this: everything is prime number. We are assuming. Then we are cancelling some numbers because we know that they are not prime. So how do we cancel that? I will tell you. So when my iteration start, this is my I value. Is I value, is it ticked or is it unticked? It is ticked. If I value is ticked, then that AR of I is a prime number. So we are printing that this is my output. Okay, we are printing that I value 2. We have printed 2. But if 2 we have printed, now don't you think if 2 is a prime, its multiple cannot be a prime number? For example, any example, 5 is a prime number. What is 5 multiple? 10. Is 10 a prime number? Not at all, not possible. Again 5 multiple, 15 is a multiple of 5. Is 15 a prime number? No. Because 15 is divisible by 5, right? Yes. We need prime numbers, which means they are not divisible by any other number, right? So any multiples of 5 is definitely not a prime. Are you understanding? Let's take one more prime number, that is 3. 3 is a prime number. What are 3 multiples? 6, 9. 6, is it a prime? No. 9, not a prime. 12, not a prime. 15, not a prime. 18, not a prime. 21, not a prime. Why? Because 21 is divisible by 3, right? So that is very important to understand. If 2 is a prime, then the multiple of 2 cannot be a prime. That is why what I'll do is, I'll tell wrong mark. Okay, for multiples of 2, I'll tell X mark. What are multiples of 2? 2, 4, 6, 8, 10, okay, 12, 14, 16, 18, 20 and 22. I am writing X mark for all the multiples of 2 because definitely they cannot be a prime. Next, my I will increment. Okay, my I will increment. So I will come here. Watch here. I hope you are understanding the logic. So I will come here. Okay, what is happening here? Okay, let me. Okay, this is I. I has come, and whenever I reaches, I have to check whether is it ticked or unticked. It is ticked. If it is ticked, write that number in the output. Print that number 3. So as soon as I write 3, 3 is a prime, but multiples of 3 is not a prime. So what are multiples of 3? Yes, 6. It is already in the wrong mark, but again you have to do wrong mark. Okay. Again, multiple of 3, 9. Multiple of 3, 12. Multiple of 3, 15. Again, see, I am putting it as X mark. Then 18. Then 21. 3 7 is 21. Right? Yes, I have put it X mark. That is done. Then so I hope you are noticing, for one I value, right? For one I value pointing, I have to do a complete search for that I value. When I value was in 2, right? I value was still there, but I needed one more loop, right? J loop to traverse through the array. Yes. When my I incremented to 3, for 3 multiple again I have to search. Yes. So I hope you are thinking, yes, there is 2 loops here, one I loop, one J loop. So when my I increments here, is this thing, is it tick mark or wrong mark? Wrong mark means don't worry. Simply continue further. Because if it is wrong mark means it is not a prime. Means for this number 4, previously there is a number which can divide this number, that is why 4 is not a prime. So don't think 4 is divisible by 2. Yes. That is why 4 is not a prime. So if it is not a prime, don't do anything, simply increment your I. Is this tick mark or X mark? Tick mark. Means 5 is a prime, print that 5. As soon as you print 5, multiples of 5 you have to delete. What are multiples of 5? 10. Okay. X mark is already there. 15, X mark is already there. Then 20, X mark is already there. Then 25, like that. Okay. Now, that J loop is completed. Then your I will increment. X mark, simply continue. I will increment. Is this tick mark? Yes, it is a tick mark. Number 7, print that number 7. Multiples of 7, put X mark. Multiples of 7, 14, X mark. 21, X mark, like this. Okay. So I hope you are able to understand here. Next, my I will increment. Right, my I will increment. And X mark, ignore. I will increment. X mark, ignore. X mark, ignore. Tick mark means print that tick mark. Right. Then multiples of 11, that is 22, X mark, 33 and all. Okay. Then I will increment. X mark means it is not a prime. Here 13. So I hope you are able to understand the logic, right? So I hope you are able to notice very fast. You will be able to get the answer. Okay. Now let's write a actual program. Now I'll tell you actually what it is. So imagine I have someone told me print the number, right? Print the prime numbers from the number 2 to 26. 2 to 26. If they want from 2 to 26, what we have to do is, they want from 2 to 26, right? Okay, now what we'll do is, we'll create one array. Okay, we'll create one array of the size. What you have to tell me, what should be the size, array size, you only have to tell me. But here, watch here, I'll create one array like this, okay, where the index will definitely start from 0, index starts from 1, 2, 3, 4 and so on. So I have created an array, okay, 0 to 26. I have created an array like this, 0 to 26. If 0 to 26 it is there, what should be the array size? Don't you think, see if they tell n value is 26, if n value is 26, they want you to print the prime numbers from 0 to 26. If they want to print prime number from 0 to 26, I have to include 26. If I include 26th index, what is the array size? I hope you know, if you start from 0 to 26, the array size is 27, right? So you have to understand the size of the array, right? It should be n plus 1. That should be the size of the array. Okay. Now next what? Next what means, we'll see. We have to initialize all of these array with not 0 or 1, but with true and false. We have to tell ourselves, we have to tell this array that initially all these elements are true, right? Because that's what I told. Initially everything is tick mark, remember? So tick mark means true value. I will be storing it in the array. True value, I will be storing it in the array like this. So I am storing true value in the array. Everywhere it is true only. Now how do we do this? Yes, till now whatever I told, let me write the program simultaneously so that you will understand. Okay. Okay. So first things first, that is, first we should have n value is 26. If n value is 26, I need from 0 to 26, means I want a new memory which will store integer type data. What's the array? Array size is n plus 1. But is it an integer type data? No, I want to store true or false. It is a boolean type array I need. Give this to reference AR. What type array? Boolean type array. This I have created. As soon as I create this, as soon as I create an array, now don't you think default values are added to the array? What are the default values for boolean? False. So false, 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 false will be there. Now you are telling, how are you so sure? Show us the array first. Let me show you the array. If I print the array system.out.println, I want to print the array. I want to print the array AR. But can I print the array AR like this? Can I print the array AR like this? No, it will print the address, right? It will print the address of that. How do I print array? I told you it is in the basic classes. Arrays dot toString is an inbuilt method just to check what is the content of an array. So I'll compile. I will execute. See, by default everything is false, false only. Agree? Everything is false by default. But I want to fill it with what? Truths. If you want to fill it with truths, you have an option. You can tell for loop int I should start from 0, I is less than ar dot length, then I plus plus. You can write like this, and you can tell ar of I is true. You can manually fill each and every element with true. That's why after filling, then I am printing the ar content. So now see, everywhere it is filled with true. Now what I would like to tell you is there is an inbuilt method for this. Instead of filling manually, you tell arrays dot fill is an inbuilt method. What this arrays dot fill will do? First you have to tell which array you want to fill. Array AR you want to fill. What value do you want to fill it with? I want you to fill it with true value like this. So if I tell like this also, the same output I will get. Watch here. Okay, if I tell arrays dot fill, as you can see, everywhere it is filled with what? True. So you have understood one inbuilt method. Next, I don't want to print the array now. Okay, next what you have to do, I have filled it with true, right? Now I want to start the for loop from here. We know that these two are definitely not a prime number, right? These two are not a prime number. but to create an array, by default index starts from 0 and 1, so we have to keep that. We don't have any other choice. But I have a choice when I'm controlling the for loop. That's why let me start the for loop, I loop, from the number 2. It should go till the end of an array. Okay, fine. So I'll start a for loop where int I should start from 2, I should be less than ar dot length, then I plus plus. I loop should start from there. Now I have a j loop, for loop int j should start from somewhere, j should be less than ar dot length, j plus plus. Okay, or how to increment we'll see later. Now if I started from here, this is my I value, right? As soon as I see this, now what I'll do is, in the previous case I told you, as soon as you see tick mark, immediately print that, I told you, right? But now we are not doing like that. To explain the logic, I have told you like that. But actually what we are going to do, the actual program is like this. If it is tick, keep it as it is. From the next number 4, make it as x mark, x mark, x mark, x mark. If you see tick mark 3, keep that 3 as it is. From the next number, 6, 9, keep it as x mark. Like that we are doing. If you are seeing 5, keep the tick mark as it is. Why? Because after doing for all these numbers, again I will search the array for only the tick marks, not x marks. So this is the logic. Okay. So 2 times I will iterate the loop. When I am iterating the loop for the first time, I am storing the tick marks. If 11 is tick mark, keep the 11, but 22 make it as x, 33 make it as x mark and all. So that after everything is done, when I again come back, now I am only searching for the tick mark, right? Linear search I am doing. Tick mark, print this 2, tick mark, print this 3, tick mark, print this 5, like that. So that is why I am not printing anything now. Now in this for loop I am not printing. Okay, fine. In that case, what we have to do here, watch here. If I value is 2, right? So this is 2. Tell me wherever j is moving. So next j should come here, don't you think? Because wherever j is moving, that location I have to make it as what? I have to make it as false here. Because 4, multiples of 2, I have to make it false. This is my j. Okay. Then my j will increment here, right? Then I have to make this as false. Now tell me, is my j starting from here? No. Because if my j starts from I, this becomes a false value. I don't want that to become a false value. That should be true only, because 2 is a prime. Tell me, should j start from I or should j start from 2 into I? Now don't you think j should start from here? That is nothing but 2 into I. Yes, that is why what I'll tell is j should start from 2 into I. J should start from 2 into I. Okay, but update, how it should happen? Next j should come here, next j should come here. Don't you think plus 2 plus 2 plus 2 update is happening? That 2 is nothing but the I value, right? 2 is nothing but the I value, right? That is why the update, what is j, the new j value is old j value plus I. Okay, so like this, plus 2 it will update, and each and wherever your j has went, it will make it as false. It will make it as false, like this. All the multiples of 2 are made as false. Okay. Now tell me, if your j, had started from I, what is the problem? If your j has started from I, it would have made this also false, but we don't want that. That is why j should start from the next multiple of I. What is the next multiple of I? Simple, right? 2 is nothing but this multiple of I is nothing but I into 1. You want to start from I into 2 multiple. This is the next multiple. That's why we are starting with that. Okay, it has done that job. So your j loop has gone till the end of the array. That's why j is till there. Then your I will increment now. Okay, watch here. Now all of this, I'll erase. Your I will increment to what? 3. So when your I increments to 3, all the multiples of 3, this is the first multiple of 3. What is the second multiple of 3? 2 into 3. What is the third multiple of 3? 3 into 3. So your j loop should start from second multiple of 3. What is second multiple of 3? 2 into I, that is 2 into 3 is 6. So from here your j loop will start. you are making it as false. So next 9, j loop will come here, you are making it as false. J loop will come here, multiple of 3. J loop will come here, multiple of 3, you are making it as false. J loop will come here, multiple of 3, 18, right? Then j loop will come to 21, multiple of 3, make it false, like this. I hope it is you are able to understand. Everything it will make it as false. Now I will clear this. Now what will happen is your I will increment, right? So when you see one thing you have to notice, your j was here, right? So what's the difference between one j and another j? Plus 3. That 3 is nothing but your I value. So when your I increments to 4, right? Is this a true? No, this is not a, what do you say, this is not a prime number. That's why stop. Okay, go for the next I value. Is it a prime number? Yes. What are the multiples of I? If I value is here, j should not start from here, because if j starts from here, it will make false wherever there is j. J should start from the next multiple, like this. I hope you are able to understand. That is why what I have to tell, wherever j goes, wherever j goes, AR of j, wherever j goes, write a false value. That's all I have to tell. Wherever j goes, write a false value. That's it. So all the multiples, so this will happen like this, 20 false, it is false. So this is what will happen. So after everything is completed, now for 5, so wherever the j go, for 20 the j will go, and 25 the j will go, and wherever j goes, it should be false, and here also it will make it as false. Then your I will increment to 6, but it is already false. I will increment to 7. Multiples of 7. What are the multiples of 7? Okay, multiples of 7 are 14, already false. So like this, all the multiples. So I hope you have understood. So this is it. Our program is this much only. Okay, our program is this much only. But I want to look into the array. After making all this, I want to look into the array. So watch here carefully. I will tell system.out.println print arrays dot to string. Which array? AR. So I'll compile, I'll execute. So watch here. This is 0th index. By default it is true. 1th index, we are not interested in that. 2nd index means the number 2 is a prime number. Okay. 3 is a prime, 4 is not a prime, 5 is a prime, 6 is not a prime, 7 is a prime, 8 not a prime, 9 not a prime, 10 not a prime, 11 is a prime, 12 not a prime, 13 is a prime, 14 not a prime, 15 not a prime, 16 not a prime, 17 is a prime, 18, 19 prime, 20, 21, 22, 23 prime, 24, 25, 26 non-primes. So I hope you have clearly understood this is how it is. So what I have to do now, I have to print the numbers. And how do I print numbers, prime numbers? Print, see this is 0th index, 1st index, 2th index, means print that index. I have to print the I value if that element is true. So if the element is true, in the array, then you have to print its index. That's it. So what I'll do is I'll write a for loop here. Okay, for loop int I should start from 0, I is less than AR dot length, then I plus plus. What I have to tell is a system dot out dot println, print that what I value. Okay, I have to tell print the I value. Should you print all the I values? No. If some condition is true, then only print the index. What condition? If AR of I is equals to true, then only print that I value. See, so now as you can see, we are printing 0 and 1. We already know that those two are not prime, so I should not start from 0, I should start from 2 only. Start searching from the 2nd index, I have to tell. So as you can see, we are printing those numbers which are a prime number. Simple program. Okay, so what I want you to do is, I want you to take notes of this. See, very simple short program. Yes. And after taking notes, I will pause the screen. Okay, so take the notes. Then if you want, you can take notes of this also, because this explains everything. Okay, now, okay, so once you have learned this, now let's see how we can make it more efficient. Okay, how we can make it more efficient. Because as you can see, when you came for 5, when you went to delete the multiples of 5, you saw that 10 was already made as false by the number 2. You saw that 15 was already made as false by the number 3. You saw that 20 was already made as false by the number 2. And only 25 you have to do manually on your own as false. So actually you should have started from this number, right? When your I was here, J shouldn't have started from here and all. J should have started directly from here. Why should the J should have wasted the time here and here? Agree? J could have directly started from there? Yes. Please understand that. Okay, your J can start from I square. It don't have to start from 2 into I. It can directly start from I square. I am telling you that only. I am telling you how it is. Okay, why? Because it is simple logic there. It is a simple formula. That is, before this number 25, all the multiples of before 5 will already occupied. For example, see, for when I started from here, what is I square? 4. That's why J started from here. But when my I started here, what is 3 square? 9. Yes, J should have started directly from here. But according to our previous program, J starts from 2 into I, right? But this 6 is already made as false by the number 2. 6 is already made as false by the number 2. So don't think here it was a waste of time. Yes. So J should start from I square. Tell me, 9, was it divisible by anyone? No. Before this number, is there any number which divides 9? No. That's why, okay, it is like that. I hope it is clear. Okay. So for the number 7, you think and tell me, for the number 7, before 49, okay. So don't you think if I is 7, your J loop should start from 49? Yes, your J loop should start from 49. Why? Because let's take the multiples of 7. This is the multiple of 7. Okay. This is a multiple of 7. But 14 is already divisible by number 2. So what and all the multiples of 7? Multiples of 7 are, okay, 14, 21, 28, 35, okay, 42, 49 and all. Okay. So 14 is divisible by 2. 31 is divisible by 3. 28 divisible by 2. Right. So I am telling you that here 14 is already checked by the number 2. 21 is already checked by the number 3. Right. Then the number comes 28. 28 in the future would already been cancelled by the number 2. All the multiples of 2 would have been cancelled. 35, which is in the future, would already be been cancelled by the number 5. Number 5 would already cancel 35. 42 would be already cancelled by the number 2. Right? 49 is a number which is not cancelled by anyone. Can 2 cancel 49? No. Can 3 cancel 49? No. Can 5 cancel 49? No. Only 7 can cancel 49. That is why to waste all this time? Yes, directly start from I square. So I hope you are able to understand here. Directly we can tell into J should not start from 2 into I, but it is I into I. And if I compare and execute the same output, proper output I will get. This is more efficient. I hope you have understood, the efficient way to calculate prime numbers. Why? Because in HackerRank, wherever in the interview, if they are talking about prime number, then please use this technique. Okay. If they want a series of prime number, then please use this technique, because this is the fastest way to print a prime number, series of prime number. To check whether a given number is prime or not, that in the basic class I have taught. Okay, that's only for one prime number. But remember, whenever you want multiple prime number, this is the way to go. Okay. So now if they tell print the prime number from 100 to 200, okay, so definitely what you have to do is, if they tell like that, so imagine this is the array. Okay, 0th and so on, this is the 100 and so on, this is the 200. If they tell they want only this prime number, right? They want only from 100 to 200 prime number. But you have to create from 0 to 200, generate all the prime numbers, but print only 100 to 200. Okay, that is all up to you. You can do that, but don't think you are wasting time. You are not wasting time here. Okay, it's still fast only compared to other methods. So it is 1.5 hours now. Okay, it is 1.5 hours. So in today's class we have seen two programs. The first program was binary search, the second program was sieve of erythronesis. Okay, so these two are important, and in tomorrow's class we will see much further things. Okay, so I hope you have liked this video, and now once you have already seen how the classes will go, how the examples I'll be showing, if you like my class, then you can join attend the tomorrow's class also to test. Okay, if you didn't like, then definitely there are two reasons why you didn't like. The thing is, you might thought I might have gone speed, right? In that case, the speed is because I have already taught these points. Okay, that's why I'm going speed. Some concepts I have already taught, that's why I'm referring, attend that, watch that video, that's why. So that's the reason. Okay, so now those who feel that yes, today's topic is enough for you, yes, class is over, but I'm talking some extra things now, so you can pause the video. Okay, you can close the video. But what we will be what I'll be telling now is that thing which I should have told in the beginning. Okay, but if I tell in the beginning, it will be like 15 minutes introduction video, but most of you are eagerly waiting for the class, how it will be. That's why I have done the topic first, then I'm talking about this class. So we'll be seeing what we'll be doing in this class. We'll be seeing about recursion programs. What recursion programs? Okay, that is, as I told you, cat in a maze. We'll be giving valid path. Okay, valid path will be given. So is the valid path exist or not? Okay, and that is one kind of problem. Then how many such paths exist? One more kind. What is the longest path, right? How many steps we have to take from this point to this point? That is one more kind of question. Okay, that will come under recursion. Then I'll be teaching you date and time API. What is that? That is, if a particular date is given, right? So you have to tell what day it is, right? From this day to another day, how many difference is there? These all things we can do using the inbuilt methods that we'll see. Then there is something called a stream API. What is the stream API? Okay, so that is for collections and all, it will be very useful. Okay, for example, if you want to sort an array, okay, you will write a big code, right? Or there is inbuilt method for that. Or if you want to remove the duplicates, again there is a big code. If you want to remove the duplicates, and if you want to remove many things like this, you have to write a different logic. If you want to extract only odd elements, if you want to extract even elements, you have to write a for loop there. But all of this can be done in a single line. That is stream API. Okay, that is stream API. So this is what we'll be doing. Okay, this is what we'll be doing. And things like hacker rank. Okay, we'll be solving hacker rank also. That is not, most of them will be easy, and most of them will be medium level hacker rank we will solve. Okay, here we'll be thinking about the algorithms, because in the medium level, if you want to solve it, you have to apply some algorithm. So we'll be talking about algorithm there also, like sieve of erythronesis, we had algorithm, right? Algorithms like that will help you in the future. So these algorithms you have to learn. Okay, then hacker rank we will do it. Then list, as I told, linked list. Remember, it is very important to learn this list. Implementation of list. How do I create a node? How do I add a node? These are the things which are important. So we'll be seeing that. Then we'll be seeing stack, queues, right? Then if a number is given for us, we'll be seeing balance parenthesis also. That's a different question. Then if a number is given to us 1 0, we have to print TEN, we have to print 10. If a number is given 11, 1 1, if a number is given 1 1, we have to print ELEVEN, we have to print 11. If a number is given 153, you have to print 153. So this program also we will see. So these kind of programs we will see, and you can think this as a advanced programming class. That's it. Please don't think this as a data structures class, okay? Because in advanced programming, little bit of everything is there. Little bit of data structures, little bit of recursion, like this, little bit of logical, little bit of algorithm. This is what advanced programming is. So see these 2 days and let's see what happens. Thank you for watching this video. Do attend tomorrow's class also so that you can judge properly. Thank you.